Hello, everyone. I'm very excited to welcome you to a new podcast episode of today's Top Tech Leaders. The goal of this podcast is to share insights and knowledge of top CTOs and product leaders on their leadership and what they've learned throughout their journey. We'll cover management tips and tricks, organizational structures, tools, and best practices on how to successfully lead your product team. Our goal is to bring valuable insights to CTOs and CTOs of all seniorities. I myself am Mark Clemens, the founder and CEO at Code Control and 9M. And for today's podcast, I'm thrilled to have Arantha as our guest today. Arantha is the founder and CTO at Parallel Carbon. She has a PhD in chemistry and experience focused on electrochemical engineering, water treatment, desalination, process engineering, and regulatory affairs. So very excited to have you with us today. For the audience already, we will talk a lot of hardware and really rescuing the world topics today. So we'll be less tech as you know it with computers and just coding, but we will go down deep into the real world. Welcome.
Thank you so much, Mark. I'm really excited to be here with you, chatting all things about hardware, climate tech, etc., etc.
Cool. So nice. So for our listeners, it would be great if you can give us a quick introduction to yourself, where do you come from, where you're located, how did you end up at this current situation at Parallel Carbon?
Yeah, of course. So my full name is Arantza Sucarmona, and as you mentioned, most people know me as Arantza. I'm originally from Mexico City, which explains a little bit of the accent, but I'm currently based in Manchester in the UK. And I moved here 7 years ago to pursue my PhD in electrochemistry. And just life made me stay here. And I'm in love with such a dynamic and cool city. And well, to be honest, my career has been a little bit of everything. I finished my bachelor's degree in chemical engineering. I started my career, as you mentioned already, in the part of regulatory affairs, but for a big chemical company, for DuPont, but I was in charge of the pesticides portfolio for Mexico, Central America, and the Caribbean. So I like to call it my dirty past. And but that was a huge school for me because it really helped me see all the issues around chemical handling. It really helped me learn a lot about what are regulations and how are they applied, and also helped me see how to manage it from different perspectives from different countries. And then working there, I realized that I wanted to do something a little bit more hands-on, a little bit more science, and I decided to start my master's in science of chemical engineering. So I quit my full-time job, went full-time in the master's, and then decided to go full on a scientific career. So I studied, I became a lecturer in the most important universities in Mexico City. And then when the time came to select the future, that if you want a life in academia or as a science, you have to do a PhD, it was okay, now what? So I decided that because I wanted to work with this amazing nanomaterial called graphene, that it's supposed to be like the next big thing around the world. No, it's this nanomaterial that is one carbon atom thick. It's supposed the best electrical conductor, the best thermal conductor. If you could hold it, it should be supposed to carry an elephant. No, it's this huge big thing. So I was like, okay, if I want to work with that, I want to work in the best place to work with, in the most important. And I realized that Manchester is where the two Nobel Prizes who isolated the material for the first time were based. And they have a huge research institute, and basically a lot of the research in the university is focused on graphene. And even Manchester, because of Manchester University, has this nickname of the graphene city. So I thought like, okay, I need to move there. So I applied and came here to do my PhD. And after I finished, while I was doing my PhD, I realized that academia wasn't for me either. That even though I liked it, it was very cool. You get to do a lot of research, but most things stay on paper. And nothing, like, it doesn't move anymore. So then I thought like, okay, if I want to do something big and like really take a real impact, then I have to have my own company. That's the only way to do it. So then I started participating and building my network and participating in awards, take my research into entrepreneurship, build a startup, went to summer schools, etc. And that really helped me build a network around that area in the UK, because I had that in Mexico, but not in the UK. So then eventually, when I finished my PhD in the middle of a global pandemic, that network helped me connect with Deep Science Venture, that it's a venture creator studio. Basically, what they do is that they recruit these PhD graduates to develop an idea based on a hole that they have realized in specific markets, like from things in climate tech, in computer, in health, more in cancer-related topics, etc. And my network led me to them, and that was amazing. So I joined them and started working. And eventually, working with them, I met my co-founder Ryan Anderson, who was already working in a direct carbon capture technology, to try to make it a little bit more affordable, to make more sense, consider all the constraints that the market had at the moment. He showed me the technology, and I was like, "That's amazing! Like, can you interview me? Like, I want to be part of your company." And we hit it off right away. And fun fact is, he's based in the U.S., in New Jersey. So I was like, okay, let's do this remotely. COVID times, everybody understood that that was the new normal. And so, yeah, we hit it off right away. And in July 2021, we spun out from Deep Science Ventures with a pre-seed investment. And then the rest is history. We have been working for the last 2 years to build Parallel Carbon, to build a technology from the ground. And we're super happy because now we have a prototype at the lab scale. And we're about to close our seed round. And literally in 2 weeks, we'll be moving on to our first lab space. So it's very exciting times for us. But yeah, that's the story of how I ended up being an entrepreneur.
Super nice. Congratulations already for this journey. Yeah, really interesting and so interesting to hear a different journey that is not just a business career or a typical developed career.
Yeah, thank you.
Before we go a bit into details, what you're exactly doing and what your role is and so on, can you give us your career in 3 words? Is there a short description of it?
I would say that it has been very diverse. I have done a lot of things. I would say it has been like a lot of passion. I would say passionate. Even everybody that I talk to, they always say that I'm very passionate. And yeah, I love what I do, and I have loved what I do from the beginning, and I become very involved in the things that I do. And the last but not least, I would say learning, because every single thing that I've done has taught me and showed me a lot of things that has built like all the different skills that I have to now be the right founder and the right CTO for Parallel. So I think that those would be the three ones.
Really cool. Yeah, I love it. All the interesting conversations we have start usually with these 2 parts, learning and passion that we have here. So I'm really happy that you see this as core elements of your career. So now you're trying to save the world. You're part of the climate tech crew. What is it exactly that you do? Can you explain that in normal human being words?
Yeah, of course. So basically, yeah, where Parallel Carbon is part of what is called the carbon industry, or the carbon capture, use, and storage industry. So basically, we know that climate change is a reality. And we know that the biggest factor of that climate change is all of those carbon dioxide emissions that are in the atmosphere that we have been producing because of the use of fossil fuels. No? We know that the CO2 goes to the atmosphere, and it's very bad. So our environment, our ecosystem, trees, plants, etc., consume that CO2 and have been doing it for thousands and thousands of years. And they have been able to remove that CO2, process it, and be able part of the environment. No? And what happened is that when these plants, especially from the prehistoric time, like these plants, animals, and everything, that they died and then they went and like the high pressure and became oil, they kept trapping that CO2, maintaining, and it stayed there. But the thing is that in the last 100 years, we have been burning it in a faster rate than that our environment has been able to process it. So in order to really mitigate and stop these worst effects of climate change, what we're seeing, like the droughts, the high temperatures, like the summer that we had last year in the UK, 40 degrees, that's insane. Like all the heat
Especially in
waves
the UK.
across Europe, especially in the UK, like it's like how? Like 40 degrees, are you serious? In a carpet house, like it's horrible. It's horrible. So we can be able to stop that and give a little bit of hope to the next generation. We need to really scale up and implement technologies that can remove that CO2 from the air. And that's where these big engineered technologies like direct air carbon capture come into place. So basically, direct air carbon capture is basically that you put something out there in the atmosphere that is called a sorbent. that removes the CO2 from the air and traps it in its own structure. And then you have to do certain process or something to release it and trap it and be able to permanently store it. So we usually pump it deep in the ground so it stays there. It becomes a mineral, it becomes a rock, and it doesn't go anywhere. Or you can put it into other products or in the circularity in the system, like for example, carbonated beverages, or you can inject it into concrete to make it a little bit more durable, etc. So you can do different things with the CO2. So that's the usage, the U that we have there, and then the storage is what I mentioned, like that you pump it underground. And then basically the idea is to have a loop where you put that same solvent that obtained the CO2, then you make it work again to put it back and absorb more CO2. No? Basically, that's what it does. Like there's already many big companies doing it out there. There's one that is called Carbon Engineering that was recently acquired for a very interesting sum by an oil and gas company. That basically what they do is that they put these things and they're aided by big funds, etc. So we realized in Parallel Carbon that these big direct air carbon capture systems have different problems. The first one is that like there's new, very exciting chemistry, very new cool things that are happening out there. But the problem is that we need to solve this problem fast. Like if we really want to stop climate change, like it's a huge pressure. And building the supply chains for these new exciting science, new materials is going to take a lot of time and money. The second problem is that most of these technologies, to do this second part that I mentioned, like to release the CO2 and have the solvent again be able to be used, basically what they do is high temperature and high pressure. And for example, at your house, if you have turned on an oven, you realize that it takes a lot of time to turn it on and it takes a lot of time to turn it off. And you're wasting a lot of energy when you're turning it off and you're just letting it cool. So these big companies that do that, of course, that means that they can't operate with intermittency. Even if they want to operate completely clean, that means that the energy has to come from renewable sources, they can't because renewable power is still intermittent at the moment. We just depend on the cycles of the sun or the cycles of the wind, etc. So there's a big issue there. So they can't operate 24/7. There's a possibility of operating 24/7 that is the geothermal energy. But geothermal is located only in very small parts of the world, and it's super expensive. So the capital investment, the capex, increases like considerably, and the opex as well. And if you're also dealing with intermittency, like your costs also go to the sky. So finding that balance, it's very, very hard. And the last but not least is that these companies, like the revenue, like not talking on the business side of things, when their only revenue comes from what we generate that are called carbon credits. So a carbon credit is basically like a currency. That it means that one carbon credit is that you removed 1 ton of CO2 from the atmosphere. So certain companies that need to achieve their net zero targets, they need to buy these carbon credits to really be able to achieve the net zero, because there's some emissions that are impossible to really remove from the carbon like balance. So they buy it from companies like us to be able to do that. Like for example, if you have recently applied, you would be able to see that they say like, oh, do you wanna offset your emission? And you say yes, and it costs you a little bit. Basically, what you're doing there is you're paying for a carbon credit. So all of us, like all of these direct air carbon capture companies, are mainly only carbon credit producers, and it's only the revenue source. But unfortunately, the carbon market has been going through a lot of changes. It's expected that the prices of the carbon credits are going to drop considerably in the next few years because there are going to be a lot more providers. So the regulations are still not clear. There's still many things that need to change in order to make it a proper thing, because it's very, very new. So relying only on that makes your whole business model a little bit more risky, especially from the investment side of things. So considering that, we designed a technology that instead of using these high pressure, high temperature systems to regenerate the solvent, we use like chemicals, basically. We use acids and bases. These very concentrated acids and bases allows to remove the CO2, allows to maintain the system in the right way. And how we're producing those acids and bases is with a water electrolyzer. So a system that breaks the water molecule into acids and bases with the help of energy. And that energy can be just clean energy, like only renewable power. And the great thing is that an electrolyzer, you can turn it on and turn it off depending on the demand, depending what you're doing, without any problems. So you can deal with intermittency. And last but not least, the amazing thing is that by breaking the water molecule, you are also producing hydrogen. That it's a fundamental tool for decarbonizing industries. So at the end, we're diversifying also our revenue sources, and we're able to do two things at the same time. We're not only removing carbon, but we're also reducing emissions, and we're able to do that in parallel. So that's a little bit of our technology, and yeah, that's more or less.
Very nice. Very, very exciting. So, and now, I mean, it sounds like out of a sci-fi movie, obviously, but fingers crossed that works out the way that you say it does. And when we had our briefing call before, you mentioned that you started operating this out of your kitchen, and now I'm seeing just massive crazy things, explosions going on, hydrogen just somewhere doing stuff.
I
Um,
know.
how is the setup? How did you start the company, and especially in the remote setup, with Ryan being in the US?
Yeah, of course. So, well, first, as I mentioned, like we were separate, like we were operating in two different countries. So when we started, okay, we need to start testing the technology and see if it works. And as I mentioned, it was the middle of COVID. It was, so these things that we were starting testing, it was around October 2021. So, okay, the pandemic wasn't that bad at that point, but there were still certain restrictions. So, and like it didn't have sense for us to rent a lab or something like that if it was only gonna be me. Of course, like a very, very new company, we have to be careful with the runway. And so what we decided is that we realized, well, as I mentioned, the technology has these two parts: the part of the mineral that is taking the CO2 from the atmosphere and regenerating, and the part of the water electrolyzer. And that also part of the name, a second part of the name as well. So Ryan, my co-founder, he has a huge expertise in the part of minerals, carbonation, this part of carbon capture per se. He has a lot of experience, and I have experience in the water electrolysis. So we could work in parallel to define that this part of the technology, each one in its own house. So we both started looking for things on Amazon, on eBay, maybe a table from IKEA, things like that. We started
So a bit
sourcing because
Breaking Bad.
a
So
little bit breaking bad completely. I wish I had a van. Like that would have been very cool. But no, I didn't have a van. But yeah, and also I think that I forgot to mention about the technology, that one of the things that we had a lot in mind from the beginning, from designing it, is that we want to use materials and chemicals that we can source directly from existing supply chains, so we can scale up faster and as faster as we could. So being able to buy these things from Amazon directly was a huge advantage. A couple of things from Alibaba, maybe, like just sourcing things. So Ryan, he was doing it in his basement. So he did it in his basement, started doing the mineral carbonation and this part of regenerating the solvent, like just in little beakers, buying little things that he could manage. And then in my case, the same way. Like I started by buying things from Amazon and designing the electrolyzer. And the first versions of the electrolyzer were horrible. It was just like a couple of bottles, like with tons of glue to avoid, because if anybody has worked with water of the audience, they know that water likes to leak. No, water likes to go places. So to try to avoid the water going everywhere, I used a ton of glue. I used a ton of tape. It was a mess, but it was very fun. To be honest, one of the things that I love doing. And yeah, that's how we started. Then we bought a couple of existing electrolyzers, tested them, opened them, and started trying things like that. And yeah, and I started in my kitchen, like in my flat. My poor husband was hating me, and then I moved into the living room. And then my husband and I realized, like in that moment, I had a baby, so of course it was a little bit risky. So okay, I need a proper office space, so we moved house. And now in the new house, I had like an office space where I can put my little table that I call my lab. But it's literally like behind me, there's a table with tons of things, a little bit of a mess. That's why I'm trying to cover it, as any lab tends to be. But yeah, and now the thing that we're really, really excited is that in a couple of weeks, we're going to move to our first proper lab space. And that's going to help us to really bring the technology to the next big scale up. So from the laboratory
Yes.
scale to actually a pre-pilot plant scale.
Okay, very interesting. And how was it for you? I mean, it's so very exciting. I think your baby must have been also very excited with all of the glue and, and chemicals.
Oh yeah, like when I have a video when I received the peristaltic pump that I was super excited. It was a very new, like it's a pump that just rotates and like pushes and like yeah, like constraints, like I don't know how to call it. Like he just presses a tube, no, basically.
Yeah.
But it looks very cool how it's rotating. And when I received it and I was testing it, oh, my baby was super happy and like pushing the buttons. I'm like, no, 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 no. But yeah, it's a lot of fun. Like you see
So
like all of those things.
clearly
Crazy.
raising the next scientist. Very good.
Yeah,
Um,
hopefully. We'll see.
cool. So yeah, but that, I mean, amazing, right? So you did that remotely. You split up the two parts of the product that you're developing into the two things that you can do separately. Um, you made sure that it works. There's some kind of proof of a functioning small scale setup, and now it's time to make it bigger. And how does this work? Never done anything in this sphere, so lead me through it.
Yeah, no, this is something that it's also relatively new to both of us as well. I've done something similar before, but not at this scale and this novelty. But yeah, it involves many things. So the first thing is, of course, the first basic thing is growing the team. No, first it's because at the beginning it's only the two of us. So now we need more team, and especially we need people that have the specific skill sets to deal with certain parts of the technology that we still have certain question marks on it. Because as we like to say, like the technology at the scale that we're at the lab scale, that we basically capture grams per day of CO2, it's unrealistically easy, no? Like doing something in a beaker is really easy. But then when you want to do it in a tank and the size is multiplied by 100, then probably you'll find problems that you have never thought of before. So we were able to find two amazing engineers that are gonna really help us do that growth. So we hired an industrial chemist that is gonna go too deeply on the certain parts of the chemistry for the mineral carbonation and the regeneration of the solvent to try to understand certain things. We're gonna buy equipment to try to do certain measurements at a bigger scale. So basically, to shorten up my answer, is just doing a lot of experiments in the lab. But now instead of using beakers and small things, it's bigger things, and start using other tools that are a little bit more sophisticated when we have that we could buy from Amazon. So of course, using the funding that we're gonna obtain to buy proper equipment, proper what we call characterization equipment, that is basically probes and things that will allow us to measure things, and then going from the data and analyzing it, no? And yeah, I'm buying tons of things. So you're able to really say like, okay, we understood the chemistry and now we understand the engineering. And I think having the right partnerships, having the right team to do that, and then building other partnerships with, for example, engineering firms or project developers that can really help you see that those extra bits that your team is not seeing. I think it's the key part of building this. But of course, like that's the answer that I have today. But probably in a year that we have achieved the scale up, I can tell you like, no, no, no. 2023 Aranza didn't see a lot of things, and these are the new things. But of course, that's my answer so far. But yeah, I think it's gonna be. I'm really excited about it. It's gonna be a huge challenge. But I'm also really excited about the team that is gonna be building that.
Very interesting, and I find very interesting because you're in a setup where you don't mention any business people. So there are two scientists, and there come more engineering people to the team. Because there must be at some point, I guess, also with investors, you need to do a pitch deck. How did it work out to do the business part of things?
No, completely. That's another great point. And yeah, actually, yeah, of course, besides these two people that I mentioned that we're hiring, we actually also hired someone with more business experience, someone that we're calling an operations specialist, someone that is going to really help us understand certain things of how we should manage things first to become a little bit more corporate, to say it in a way. In a second way, also to start approaching that project planning in terms of customer acquisition, etc. So my answer is divided in three parts. Like the first one is like, yeah, we're hiring someone. The second one is like when we were both working in Deep Science Ventures before we spun out, we were able to have like a lot of great advice and a lot of preparation from the guidance in there in Deep Science Ventures. Because one of the great things about these venture creator studios is that they start teaching you the skills that a founder needs to have. No, so even from the beginning, like how to talk to investors, how to approach investors, how to understand a cap table, like all of those basic things in terms of the business, they start in training you. And of course, Ryan and I, from our career, we still, even though we're very technical, we have been able to learn certain things. But of course, it's mostly theoretical, like, oh yeah, let's build a business model with the business model canvas and all those type of things. But at least we kind of understood it. And then as we started growing the company, well, before growing the company, we started working in the company and developing things, etc. Being so close with our investors really help us also discuss the potential, see the things. And Ryan has a lot of expertise in the carbon market. So he knows a lot of how it's behaving, and he's an expert in techno-economics. So that has really helped us approach this part and knowing a little bit more part of the business. So yeah, we have grown a lot. We have learned a lot, especially during the seed round. It's awful. It's very stressful. It's very tiring, but it's a huge learning experience because you starting asking the questions that probably you haven't asked before. No, like certain things about milestones, about team, about the different things. And yeah, like totally that part of lacking a commercial founder, it was something that it was a very important thing with a lot of investors. And that's something that definitely is part of our it's going to be the big next hire that we do after these three that are already onboarding. The next big hire is going to be someone related on the commercial side of things, because we need someone that is going to really help us build that strategy of how we're going to acquire the customers in the future, and someone that probably knows. So if you're listening to this and probably you're interested,
I just want to say, send me the job ad. I'm applying.
Send me a CV. You can contact me. But eventually, of course, this is something that we believe that we definitely need. And even though we have certain skills that will help us understand that commercial part, we definitely need someone like that in our team to really build that. So this person will eventually become a CCO, a COO, depending a little bit on how we define the structure of the organization. But yeah, definitely that's the next big hire.
Cool. Very interesting. So one more question before we need to slowly wrap up, and that is, what is the plan? You're going to build massive factories, and that all remotely, or what's the?
I love it.
How does the future look like?
It. Yeah, okay. So the immediate future is basically how we have thought of it is that we're building this team in the UK, that it will be basically the R&D team. No, we're gonna be understanding the chemistry, understanding engineering, building up, etc. And the US will stay like the commercialization arm of the company. There's many reasons for that, but the main one is that at the moment the US regulations are allowing a lot of our companies like ours to really access a lot of subsidies and a lot of help to be able to build this technology. So by removing CO2, you access certain subsidies that help a lot the revenue model, of course. So that's one of the main reasons. And the other one is also because it seems that the US is going to become a big hub for these companies, especially when you do it as pilot plants and as you scale up. No, a lot of our idea for the future is that we're going to have ownership of these big plants up to when we reach what we call the TRL9. So basically, when we have a full commercial plant, like what we call the first of a kind, etc., something that is already big and operating, removing thousands of tons of CO2. And then the ownership of the projects is going to start decreasing slowly over the time. So when eventually we will only be providing and selling a license instead of the carbon credits directly. So it's something else we're seeing in the future. Once again, we're also very open because, as I mentioned before, the carbon market is very, very dynamic, and we don't know if these potential business models might change, but that's the idea so far. So that's how we're thinking it at the moment. And the remote part, I completely agree. It could come with its own challenges. I think that from the beginning, what Ryan and I have built is and take advantage of all of these amazing communication tools that the pandemic allowed us to see that were possible to use, and allowed us to build a lot of trust around. So that's the idea. That's how it's going to be working, and then we're going to be working with engineering partners in both sides of the ocean, to say it in a way. But having of course the R&D located in a single place, of course that helps eventually to grow a little bit faster, as we hope we will.
Cool. Now you need to give me one last question. How big will one of those plants be?
Okay, so you can imagine the idea of this first of a kind. What we expect that is it's going to be removing around 60,000 tons of carbon dioxide from the air. The size of the plant is more or less, if you could imagine, like a football field. but only the
Mhm.
field, like literally only the
Yeah.
part that is marked where the players play. It's basically more or less of that size for this type of technology.
And
Um,
high or narrow? Will it be like some massive building, some futuristic architecture on top? Or
No, to be honest, it looks very, very simple. The part of the electrolyzer is if you imagine these shipping containers, it's gonna be something
okay.
like that.
Hmm?
So something very simple. The part of the regeneration of the minerals is just like water treatment tanks. So nothing cool, to be honest. Very simple.
Yeah, so we need to find some
Everything is
graffiti
super
artists for
simple.
everything around.
Yeah, probably eventually when parallel carbon sets off, like maybe we'll hire an architect or something to make it look cool. But at the beginning, it was just like any other chemical plant, because also the part of the minerals, it would look like what we call the trays on the racks. Is if you have ever bought bread in these big supermarkets that you see that they have it on trays, basically it's that. So it's something very, very simple from the beginning. And in terms of the height, that's a great question. It's something that we will still, like we believe in the next big part, we're gonna really see how tall it will be. Our idea is that it's not that tall, so it doesn't become like a huge problem, especially to move around and manipulate,
Mhm.
etc. The idea is that it will be maybe the height of a three-story house,
Mhm.
exaggerating. But
Okay.
most probably will be something like shorter. It's much, and the thing that, to be honest, occupies a lot more space is what we're gonna use in the renewable energy, the solar panels, the wind
Okay.
turbines. Those things tend to take a little bit more space than the other part of the technology. But yeah, it's something super simple. It would look like just any other chemical process.
Absolutely fantastic. I'm already a huge, huge fan of you and the company, and
Thank you,
I'm
Mark.
very excited to observe what's going to happen. Um, do you have, for the end, some advice you would give other technical leaders? Any books, resources, any mindsets that you keep while you do this?
Yeah, of course. I think that the best thing is to always be close. At least for me, it has been really good to be close to our investors, to keep them as real good advisors and ask any doubts that you might have, especially if you're a technical founder. It doesn't come that natural from the beginning, like to have this type of harsh conversations. Like just also network, go out there, talk to people here, and of course keep a lot of eyes on the what your competitors are doing, so you can also see the good things, learn the good things, and learn from the bad things that they're doing. In terms of resources, I would say I got a book that it's called From Expert to Executive, that it's written by Edward E. Tyson. And that is really helping me now that I'm doing the transition from just being a founder to actually being a team leader. That is something that, to be honest, I was very scared about when we started hiring people. I was super excited, like, oh, people. And then the date of their joining in their onboarding started to came close, I was like, I'm gonna be managing a team. I've never managed a team. I'm gonna be a boss. I'm gonna be that person that they complain about when they go home. So if they are gonna complain about me, I want them at least to be a simple complaint, not that I'm the worst person on earth. So I really needed to develop a lot of my leadership skills and especially my mentoring skills in many ways. So I've been reading that. And also I just finished an amazing series that I was like obsessed with it. I couldn't stop watching it. That is called Big Babe on Netflix. That yeah, it tells you a lot of the story of these Juul, the big e-cigarette. But in terms of the story and a product is interesting. But if you see it with the eyes of a founder and start analyzing all of the mistakes that the founders did, is fascinating. Like really, it's really interesting to dwell on it and see like, oh yeah, and to be honest, mistakes that could have happened to anybody. A couple no, a couple like they were like, come on, but some of them were like, wow, yeah, that could have happened to any founder. So I think it's worthy to keep inspiring yourself with the stories of other companies, stories that have done companies that have done great and stories that have busted horrible. And even chatting with employees from current startups and hearing like, oh, what is your company doing right? Like, do you like it or not? Like when you're doing even with friends, no? So I think keep hearing those stories can really inspire to see what things you could do right and which things you could go wrong, and always see any mistake that you do as an opportunity of learning. I think that that's the most important thing.
Really nice. Thank you so much, Amantha. And thank you everyone for listening to today's Top Tech Leaders podcast. Obviously, subscribe to the channel, share your feedback. And I want to give one more wisdom if you haven't had enough wisdom of Aranza already, something that she said in the brief before that I thought was really interesting, that scientists know what questions to ask and who to ask, so they're smart enough to build the right network and humble enough to know that they don't know everything. So
Love.
with these words, thank you so much. Hope to have you as a guest soon again, and have a lovely day.
Thank you so much, Mark. It was a pleasure.